0.05. So let's get started. Alright, so in the past, in semester A, you've talked about skew lines before. I'm sorry, you have not talked about skew lines before. You've talked about intersecting lines, you've talked about parallel lines, but you've never talked about skew lines. So skew lines, what they are, the actually correct definition, is that they are lines that do not intersect and they are not parallel and not in the same plane. So if I take a look in my drawing, I want to come up with two lines that do not intersect and they're not parallel. Well, for that to happen, I have to pick two lines that are not in the same plane. So for example, if I looked at this right side of this box right here, if I tried and pick two lines that were in this plane, they would either intersect or they would be parallel. So you have to pick two lines that are not in the same plane. So for example, I can pick AB and I can pick CD. Those two lines are not in the same plane. AB is in this blue plane. CG is in the plane that is closest to us, that is standing up straight. They are not going to intersect. This one's going to keep going up, and then this one's going to keep going across. But since they're on two different planes, they're not going to intersect, nor are they parallel. To be parallel, you actually have to be in the same plane. So some definitions will actually leave out this part, assuming that the kids know that if it's not in the same, then it cannot be. If it's not in the same plane, then it definitely cannot be in parallel. They definitely can't be parallel lines. All right. All planes are either parallel or intersecting. That goes for every single plane. So if I looked at the sides of this box, those planes would be parallel, and as well as the tops of that box, parallel. If I look at the top and the side, those are intersecting planes. Okay, so all planes are either intersecting or parallel. Here are some real life figures that show skew lines, because skew lines are kind of hard to see. So in this first picture to the left, I have a wall. This is not my house. I just Googled images. So these two lines are in fact skew lines. They're not on the same plane and they're not going to intersect. So therefore they are skew lines. I had lines on here, so I'm not sure what happened to them. I'll just choose some lines. How about this one? Oh, and then this brown one right here. Those two are not on the same plane and they will not intersect, therefore they are skew. Same thing with this street sign and same thing with this piano. Alright, so anytime we have a plane and we have a line that is on that plane, that line is going to separate that plane into half planes. Half planesies, right? So I can look at it as the line going diagonal like they have in picture A. I can look at like the line going vertical like they have in picture B. I can also look at the line going horizontal like I'm doing now. And guys, I actually don't have to look at those three options. I can put a line going like this. It does not look like that line cuts that plane in half. But because we know a plane extends forever, then that means if I stretched out this side to be I could get it to the same amount as this side. Alright, because planes extend infinitely in all directions. So therefore, any line is going to cut a plane in half. Okay? And then also you want to talk about a half plane consists of all the points on one side of the line. So we're talking about a half plane. I'm just talking about all those points on one side of the line. Alright, another terminology that I don't know if you've ever heard, is dihedral. A dihedral angle is when two planes intersect. For example, let's take a look at this top picture. Here is two planes intersecting, so they form that angle right there. Alright, actually in the lesson they talk about two half planes intersecting, because technically this is a half plane and then technically this is a half plane that are intersecting. But it's all fancy, so I just say two intersecting planes. will form a dihedral angle. It's just a fancy word for angle. All right. Any angle along those intersections of those two planes will be the same measure. Okay, so now you see a total of 3, the 2 that I draw and the one that was already there. Those 3 angles are all going to be the same measure. I could draw infinitely amount of angles, and all those angles would be the same. Okay, just think about if you fold a piece of paper, that angle is going to be the same no matter where you would measure that angle on that fold. Dihedral angle. All right, this starts section 1.05. If you noticed in the title in slide 1, it was called Polyhedra. Well, polyhedra is plural for polyhedron. So here on this left side are examples of polyhedrons. On this right side, examples of non-polyhedrons. So what is, in fact, the difference between the two? If you look on this right side, you notice there are a bunch of circles, and on the left side, there are none. And that's what makes a polyhedron a polyhedron. A polyhedron is a solid that has bases that are actually polygons. Polygons are two-dimensional figures, okay? They have edges, okay? That's why this cylinder is not a polyhedron, because its base is a circle, and a circle is not a polygon, okay? In order to be a polygon, you actually have to have an edge, and we're going to talk about what an edge is in a second. So these are examples. The bases are just your identical pieces, your top and bottom of your identical pieces. So this and this would be a base. Even though it's not like you would have to stand that up. Those two, the arrows, those two triangles are actually the bases of that figure. Okay, and then we also, well, I'll talk about that in a second. So if it has anything to deal with circles, not a polyhedron. All right, and here's actually the definition. A solid that is bounded by polygons that encloses a single region of space. Polygons meaning it is not a circle. It has edges. So there are 2 main types of solids. One is a prism and one is a pyramid. You can see how a prism has 2 sides exactly the same, whereas a pyramid just has a base, one base. Okay? So let's take a look at these. We always identify the prisms by their base figure. So if I look, this looks like a square, but I'm not sure it's a square, so I'm going to call it a rectangle, so it's a rectangular prism. This is a hexagon on its base, so this is a hexagonal prism. This is a pentagon on its base, so it's a pentagonal prism. Same thing with pyramids. We look at the base, this is a rectangle, so rectangular pyramid. This is a hexagon, so hexagonal pyramid. I have a hard time seeing how many sides though has. But you always just use your base to name what your prism or pyramid is. So parts of a polyhedron, I've already kind of talked about this. The face is just the sides of the polyhedron. So in all 3 of these pictures, they all have a triangle as a face. This one at the end, though, this right here is in fact a rectangle. Okay, I know it looks like a parallelogram, but if we would stand it up, then you would see the rectangle. It doesn't always have to be triangles. For example, if I drew a cube, okay, my faces are now squares. Okay, these are all faces, and of course I have bottom pieces and sides you can't see because I'm not that good of a drawer. There you go. Alright, so those are the faces. Edge is the line segment formed by the intersection of 2 faces. So here is a diagram of an edge where this face and the one on the side meets. In my cube picture, oops. Okay, all these are edges. All of them. And then last but not least, a vertex. A vertex is where 3 or more edges meet. So if I look at my rectangular prism, because I don't think this is a cube, here is an edge, here is an edge, here is an edge. So this is a vertex. Same thing with here. Even though it looks like I only have 2 edges meeting up, remember, there is in fact that bottom piece that you can't see. There's going to be that bottom line. So this is a vertex. Same thing with this one. It's going to be this, this, and then that one. And then in this picture, they identify all the vertices, I believe. Yep. All right, so the only thing I didn't cover in this lesson is nets, because nets is something I kind of have to do live to show you how it works. So please make sure you attend Monday, 1 o'clock. See you then. Bye.